Alright, so let's take a look at this idea of solving a system by what we call substitution, rather than to graph. Alright, so the idea is kind of like graphing. The idea is that we take two equations and what we're trying to do is we're trying to combine them together. So just like with graphing where we took two lines and combined them onto the same grid, we're taking two equations and we're trying to combine those together as well to find our solution to the system. Alright, now substitution is a process where what we want to focus on is we want to basically combine these two equations. But our goal here is to try to get it down from two equations with each having two different variables down to a single equation with only one variable. Because if it only has one variable, we can solve it. Alright, so here's the idea. The first thing you want to do is you want to look at your system and you want to look at your two equations and you want to decide for yourself which one is the what we call the substitution equation. In which case, I happen to know it's this one. Okay, so what I would do in your notes is just put a notation next to it that this is the substitution equation. Alright, now what I would also put in your notes is how I know that. What I'm looking for when I was comparing these two equations was this isolated variable x. Okay, so you always know which one's your substitution equation by looking to find that isolated variable. And it doesn't matter. It could have been x like this one, it could be y, we don't care. As long as we've got that isolated variable and then equals and then everything else. Because basically what this is saying is that in words that whatever answer x is, that x is the same as what's on the other side, 5y plus 3. So if I knew what x and y were, I could plug them in and what I would get for x would be the exact same thing I would get for 5y plus 3. So they're basically equivalent to each other. Alright, so what should happen here is that now that we've identified this as the substitution equation, this is basically telling us what to do. It's telling us to go to this other equation that we haven't touched yet and make this substitution. We're going to, everywhere we see x, we're going to swap it out and swap in its equivalent, 5y plus 3. So what I want to do is I want to take this other equation, the one I haven't touched, and again, I'm going to swap out x. So basically I'm going to rewrite this equation but with a big blank spot where x used to be, like that. Okay, and the parentheses are helpful too because sometimes we'll end up in situations with negatives or with distributive property, and so always put the parentheses in place of the variable we're swapping out. Alright, now just like it says over here, we're swapping out x because what we're going to swap and substitute in its place is 5y plus 3 because these two things are the same thing if we knew what x and y were. So what I can do is I can put in 5y plus 3. Okay, and this is the big idea. This is what we're trying to accomplish. I went from two equations, each with two different variables, down to one equation. Granted, it's a combined equation, but it's one equation with only one variable, y. Okay, and this we know from chapter 1, we know how to solve this. So we clean it up by doing distributive property. We combine our like terms with the y's here. Start undoing things. Subtract 6. And then simplify, and we get y equals negative 1/2. Alright, so here's part of our answer. This is the same type of answer that we got yesterday. We're just looking for that combination of x and y that works for both these equations. So in this case, y is negative 1/2. Okay, we still need to find x though. Alright, so what we do is we basically repeat this process but a little bit easier. Okay, because now I've got a new equation. I've got this one, y equals negative 1/2. Okay, so this will be our second substitution. This is substitution number 2. And what you do here is we take this answer and we go back to either of the original equations, either this one or this one. Okay, and you can pick either one. Nice thing is it doesn't matter, so tend to pick the easier one. I think this one's going to be easier to work with. So what I'm going to do is I'm going to put this right here. And again, I'm going to do what substitution number 2 is telling me to do. It's telling me that y is equivalent to negative 1/2, and so everywhere I see y, I'm going to swap it out, and I'm going to swap in negative 1/2. So over here in blue, I'm going to put x equals 5 times blank plus 3. We're swapping out y, and in its place, we're putting what y is equal to, negative 1/2. Okay, if we do the math, 5 times negative 1/2 would be negative 2.5. And then negative 2.5 plus 3 is positive 1/2. All right, so there is my solution to the system. Okay, this should be the only x and y that together make this equation work and this equation work at the same time. If we were to go back to our other method of graphing, if I were to graph these two, this is where these two lines would cross. All right, so let's check our answer. It's always good to check these things because you can see how many steps it takes. Easy to make a mistake. So we take our answer, and let's again color coordinate this. So I'm going to take my equation in blue. X equals 5y plus 3, where I've now found that x is 1/2 and y is negative 1/2. I do the math. 1/2 equals 5 times negative 1/2 is negative 2.5 plus 3. 1/2 equals 1/2. Checks out. All right, but this is not enough. It's got to work for both. So now I take my equation in red. 2x plus 4y equals negative 1. And again, in place of x, I put 1/2. In place of y, I put negative 1/2. And I do the math. 2 times 1/2 is 1. 4 times negative 1/2 is negative 2. 1 plus negative 2 is negative 1. And negative 1 does equal negative 1, so that checks out. So it works for both equations, so this is the solution to my system. Okay, and the idea is we did this without graphing, and this is much more mathematically correct. Graphs, we can always be off a little bit. We can always mess up the line or graph it crooked. Okay, but here, mathematically, this is the exact location where these two lines are going to cross, and it's the only x-y pair that's going to work for this equation and this equation simultaneously. All right, so this is called solving the system by substitution.